Hello and welcome. My name is Tracy, and in this video I'll walk you through the basics of placing and persisting AR data in a PoseMesh domain. PoseMesh domains can be thought of as virtual real estate on top of physical spaces. It's a marker-based coordinate system in which Lighthouse QR codes serve as entry and calibration points for apps built on the PoseMesh. This allows for the anchoring of digital information in physical locations so that they'll persist across app sessions. For this simple persistent AR experience, we'll calibrate into a domain, place different colored cubes around it, and save them to the device's local storage. Then the next time we open the app and calibrate into the same domain, the cubes will still be there where we left them. Before getting started, please make sure you've set up a PoseMesh domain and configured your development environment and Unity project settings as shown in the Quick Start Guide. If you need details on how to do either of those, you'll find links in the description below. Please also open this written tutorial page in the documentation, as we'll be copying some code from it. I've already done the setup and created a new 3D project in Unity named Persistent AR. The packages you see here are the ones we'll be using today, notably AR Foundation Integration, ConjureKit, Manna, ARKit, and AR Foundation. Starting with the default sample scene, we'll delete the main camera and create an AR session, as well as an XR origin. In the XR origin, add an AR Raycast Manager and an AR Plane Manager. Now create a canvas for the app's basic UI elements. Inside it, we'll add a button for placing cubes and adjust its parameters. Next, we need an empty game object to hold the calibration UI elements, which we'll call Calibrate UI. Inside this, create an image so that it covers the top of the mobile screen. And duplicate it to cover the bottom as well. Add some text here about calibrating into a domain using lighthouses. The last thing we need is a cube marker. I'll make it 20 centimeters and set it to inactive since we only want to see it after we've already calibrated into a domain. That's it for the UI. Now let's start with the ConjureKit implementation. Create an empty game object, as well as a new C# script named Persistent AR in Domain that attaches to it. Inside the script, we'll import ConjureKit, Manna, UnityEngine.ui, UnityEngine.xr.ar Foundation, and UnityEngine.xr.ar subsystems. We need a serialized field for the AR camera, and strings for the app key and app secret that we got from the PoseMesh console. If you don't already have these, refer back to the Quick Start Guide. ConjureKit and Manna will need variables to hold them, so let's add those next. In the start method, we'll initialize ConjureKit with the app key and app secret, and pass frames from the camera feed to Manna for calibrating into domains. For this next part, we'll need a couple more serialized fields for the cube marker and for the calibration UI. as well as a private bool to store the calibration state. Here in the start method, we call onLighthouseTracked when a Lighthouse QR code is tracked by the camera, so let's define that now. If not already calibrated into a domain, it sets the calibrated bool to true, deactivates the calibration UI, and activates the cube marker. Next, we'll add the cube placing mechanism. Start by adding serialized fields for the Raycast Manager and the Create Cube button. Then declare a list to store the AR Raycast hits. In the update method, we'll raycast from the center of the screen to any detected AR plane and place the cube marker where the raycast hits the plane. Next, we need a placeCube method that instantiates the cube there. This will be called from onCubeButtonClick, which gets a random color and passes the raycast pose to the placeCube method. For the random color picker, we'll need to import UnityEngine.random. Back in the start method, attach an event listener to create cube button that triggers onCubeButtonClick when it's clicked. For the data persistence part of the script, we'll save the data about the spawned cubes in the device's local storage in JSON format. Because Unity-specific data types like Vector3, Quaternion, and Color aren't serializable into JSON, we have to write custom serializable classes for them. So create a new C# script called SaveData. And just go ahead and copy this whole script. We won't go into a lot of detail on this, these classes are just used for converting the data types to and from JSON. Back in persistent AR in domain.cs, create a field for the SaveData object. Now we need two methods. Save locally for serializing the data to JSON and saving it to the device's local storage using Unity's PlayerPrefs class, and load locally for loading the JSON data, deserializing it, and placing the cubes in the scene. In the onCubeButtonClick method, in addition to placing the cube, we'll save it as well. And here in onLighthouseTracked, after successful calibration into a domain, we'll call load locally. That's it for the script. The last step is to assign all the references in the Unity editor by dragging and dropping them into their corresponding serialized fields. We can now build and run the project. First, calibrate into a domain. Then place some cubes in it. If I close the app and reopen it, and calibrate into the same domain, here are the cubes. That's it, as simple as it gets. I hope you enjoyed this introduction to persisting AR data in PoseMesh domains, and thanks for watching. Please join our Discord server for ConjureKit SDK support or just to show us what you're building on the PoseMesh. See you there, and thanks again.